What's up, everybody? Welcome back to another live stream from Scalar Learning, and today we are continuing with SAT problems, solving systems of linear equations level 3. All right, let's just do a quick sound check, make sure we're good to go here, and we are. And without further ado, let's jump into it. Now, we've got a new SAT coming up in December. I think it's December 3rd, but I got to double check my dates. Anyways, for that December date, we will again be doing a week-long prep course leading up to that SAT, just a cram session to knock out any math questions. So I encourage you, once those times are posted, to definitely check in and work through those problems with us every day and get you ready, get you on point. I've had so many messages from so many awesome viewers and subscribers telling me how much working through the problems with me or watching me do the test materials has helped them. I heard people saying they've gained 200 points, 100 points, whatever it is, which is amazing. But I have to believe that it's working. And it's all out there. It's for you guys for free. So I really encourage you to jump on and watch and take advantage of the explanations that I try to provide. All right, without further ado, let's jump into the problems. And we are doing, where is it? Whoops. Systems of linear equations. Now, as always, I am doing these problems for the first time. I have not seen them before, and that is the point. That's part of the fun. And it's also part of the value for you is to actually see me work through these problems in real time. And you never know, sometimes I do make mistakes. I'm not perfect, which I think is also hopefully a little bit part of the fun. Okay, consider the systems of equations above where a is a constant. For which value of a are there infinitely many solutions? I can already tell you what we're dealing with here is we're dealing with two lines that need to be parallel. I'm sorry, two lines that need to be essentially the same, where they overlap. That's what we're talking about. So we need to make sure that that a constant provides us a function that is the same as below, 3y minus x minus 1. So I can, let me see here. All right, I already know a has to be 3, okay? Because the only way, all right, a has to be 3. The only way that these two equations would be the same. So you have to know what infinitely many means. The reason why infinitely many solutions has to be the same line is because they're right on top of each other like that. That means they intersect at every point. A solution is just these intersection points. And if they're right on top of each other, they have infinitely many. If they're regular, just lines like this, they have one solution. And if they're parallel, they have no solution, 0 solutions. And the way these become the same is we need a 3 multiplying the y, so a has to be 3. That will give us a -1. And that, oh, wait a minute, x over 2. No, I spoke too soon. All right, I spoke too soon. So it can't be 3. Hold on. May not have a solution. This actually, now I'm thinking it doesn't have a solution. Let's do this the standard way, which is where I put this in the slope-intercept form. It gets a little easier when I do that. I just realized 3 won't work because it doesn't match up the x terms. So here's what I'm going to do. I'm going to isolate y for both of these. I'm pretty sure it's actually no solution. But the bottom one is 3y equals x plus 1. So I moved the x and the 1 over by adding them. And then I divide everything by 3. I get y equals 1/3 x plus 1/3. Okay, now it's a little easier to see. And then this one's going to become ay minus 1/3 a plus x over 2 equals 0. I'm going to move everything over. It'll be ay equals negative x over 2 plus 1/3 a, and then divide everything by a, and it's, let me put it up here, y equals negative x over 2a, right? Because I'm dividing by a and dividing by a here, and that just actually goes, the a's go away here. Divide this by a and divide this by a, and these a's cancel out. That goes away, and we just have 1/3. Okay. So let's see. Oh my gosh, I keep having to amend myself. I actually think this will work. So what this is coming down to is we need to know where negative, hold on, let me think here. 3 Yeah, here we go. We need to know where 1/3, this coefficient, is going to equal -1/2a, which is the coefficient for this guy. Just the way I wrote it looks a little funny, but you could write this as -1/2a times x, either or. So we need to know for what value of a is going to make these two values equal, because again we want equivalent lines. So now I'm just going to cross multiply. So I'll stick the negative on top. Doesn't matter which, top or bottom. So this becomes -3 equals 2a, and we divide by 2. So a equals -3/2. So you see that I actually assumed it was 3, wrong. Then I thought no solution, wrong. And now I found it's -3/2. What's the moral of the story? Work through the problem. Don't go to a shortcut. And I think my issue here was I forgot that my first step should have been to distribute that, multiply out by 2, because this x/2 first needs to become an x. Then we can really see the clear picture. It's a tough problem. Good level 3 problem. Okay, next. Consider the system of equations so for these equations, what value of a are there no solutions? Remember I said no solutions are where the lines are parallel. It means the slopes are the same, but the y-intercepts are different. That's it. I'm going to do the same dealio here, and I'm going to divide by a, and I'm going to get them both into slope-intercept form. So this is y equals 2/ax for the top one, plus 1/2. And the bottom one is already y equals 2x plus 2. Now the nice thing is, oh, whoops, what am I doing? Excuse me. That should be a, because I divided this entire thing by a and this thing by a. Okay, now we need, this is going to be fine. So we don't have to worry about this so much, because I think we just have to check with the y-intercept after the fact. First of all, we have to have identical slopes. So that means that 2/a has to equal 2, which means, of course, that a has to equal 1, right? The only way that we can get this to work is this has to be 2/1, which is 2. So a has to equal 1. And does that mean, does it work over here? Now, if we know that a is 1, okay, we just need to make sure that these y-intercepts are not equivalent. But look, they're not. It's 1 and it's 2. They're not equal. There you go. So if a equals 1, there would be no solutions for this guy. Now with these, you have to be so careful because this is not multiple choice. We don't have any guideposts. We don't have any checks or balances saying, oh, I looked to, my answer is not there or something like that. So we have to be very precise, make sure we're good in order to get these right. And it's good. There we go. Next. Consider this system of equations. If Rs is the solution, what is the value of R plus S? Got it. Okay. Let's solve using... well, we can do either substitution or elimination. I'm going to go with... hold on. 0.7. Let's go with... it doesn't matter, but let's go with substitution. How about? All right. 5.2s. I'm just trying to figure out which one's the easiest to do, and I think I know. This one is, I'm going to distribute this 0.7. 0.2. So let's distribute this guy. 0.14. This, you can use a calculator if you need to. Okay. So what I'm going to do is I'm going to... I know. I'm going to subtract... I'll bring this guy down here. I'm going to subtract 5.2s from both sides, and I get 0.1r equals negative 5.2s. I'm going to multiply both sides by 10. I get r equals negative 52s, just to make life easier. Then I'm going to take this 52s And I'm going to plug it into R in this equation. So then I've got 0.7 times negative 52s, oops, plus 0.14 plus 3.2 equals negative 3s. And then, wait, 3.2. Oh yeah, I could have combined these. I didn't even see that. So then 0.7 times this, I'm going to try and do to my head, is negative 36.4, right? I'll have to double check that. I have to be careful because it's not, actually, let me just do it. 0.7 times 52 equals 36.4. Okay, good. S, these guys added up is 3.34 equals negative 3s. So I'm going to add 36.4s to both sides. 36.4s. To move this down here. This goes away. 3.34 equals 33.4s. Oh, look at this. It's nice. 33.4. We actually don't even need a calculator. Because look, that's clearly 1/10 of that. So it's S equals 0.1. And then if we want to find what R equals, we have that nice equation. I'll use the top one. So it's 5.2 S plus 0.1 R equals 0. So S equals 0.1. So if I plug in 0.1 for S, that's 0.52 plus 0.1 R equals 0. 0.1 R equals negative 0.52. And then divide by 0.1, R equals negative 5.2. Yikes. Okay. And then they want to know what is R plus S. So we do negative 5.2, which is R, plus 0.1, which is S, and that equals negative 5.1. I'd say that I wasn't as careful as I should have been with some of these calculations. If I were really doing this, I should have been more diligent with the calculator because there's a lot of room for error with all these decimals. This is a hard problem because there's a lot of places to make a mistake, and it's not even multiple choice. And it says round to the nearest tenth. We didn't have to round. Let's just give it a shot and see. Hold on. So we got a -2. That's weird. Ooh, okay, let's double check. We can check for this and make sure it's right. Okay, S equals 0.1, so that's 0.52. R equals negative 4.2. That's correct. So it works for this equation. Now let's check this one. R equals negative 5.2 plus that is negative 5, so it's negative 3.5 plus that is negative 0.3. Actually, I think it's right. Oh, it's not 5.2. Oops, it's negative 5.1. That's what we got. It's got to be right. Yeah. Okay, difficult. That was a hard problem in the sense of what to do is not necessarily super difficult, but with all those chances for mistakes, it's tough. For what value of k does the system of linear equations and the variables x and y have no solutions? Again, we're talking about parallel lines. Same slope, different y-intercept. I'm just going to isolate y. So we got negative 6.4x equals 4y plus 2.1. I'm going to subtract 2.1 from both sides. And I'm going to just put the 4y on the left side, just kind of rotating. Doesn't matter. I like it better on that side, minus 2.1. Divide everything by 4. Y equals 64. Hold on. It's calculated. Let me just get a nice decimal. 6.4 divided by 4 is 1.6. Yeah. 1.6x negative, right? Minus 2.1 over 4. Minus 0.6. Okay, that's a pretty nice equation. Now let's look at the second one. We've got I'll write it up here when we're ready. Ky plus 3.2x equals 5.8. Ky, I'm going to subtract 3.2x, subtract 3.2x. Ky equals negative 3.2x plus 5.8. Divide everything by k. And then we end with, I'll give the second equation in red. Y equals negative 3.2 over k plus 5.8. What? Over k. Oh, that's fine. All right, so the key here is that, and I forgot the x. The key here is that these slopes values right here have to equal each other, which means that k has to equal 2. I can already tell, because negative 3.2 divided by 2 is negative 1.6. So k has to equal 2. And this works as long as if I put k in here, I don't get the same y-intercept. Clearly I don't. I'll get 2.9, and that's negative 0.6. So we're good there. So I believe if I've done this correctly, k has to be 2. Let me just double check. Negative 3.2. Yeah, I think that's right. All right, let's go for it. Let's see what's up. Yeah. Okay, last one. Consider the system of equations. If AB is the solution, what is the value of A times B? Okay, so it's the same deal. We have to simplify. I mean, they gave us a really complicated one, so let's just work out the first one, and then we'll deal with the second one. So we got 12 minus 3a minus b equals 15a minus 10b plus 8. Okay. And then we've got, so let's get all the a's together. Actually, let's put all the variables on the left side, the numbers on the right side. So I'm going to subtract 8, subtract 8. I'm going to add b, gonna add 3a, and we've got 4 equals 18a minus 9b. Okay, that's my first one. Now let's look at the second one. The second one's gonna be a little easier. I'm gonna go ahead and just distribute ahead of time. That's gonna be 6b. Oh, what am I doing? Oh yeah, that's what no, sorry, that's fine. I actually was initially thinking the constants would go on the right side, and I did it the opposite, but that's okay. Now we have 6b minus 9 equals 7a. So let's subtract 6b, and we've got negative, here, I'll put it up here. Negative 9 equals 7a minus 6, minus 6b, just so everything is lined up. Let's get rid of this now. All right, now we're in a pretty good spot. We need to solve this system, and I want to use not substitution. I want to use elimination because, well, it's actually arbitrary. It doesn't matter. You can use both. But I like elimination better here because I can multiply these guys pretty easily and get them to match up. So I'm going to multiply the bottom equation. Well, you're going to see what I'm doing here. Multiply the bottom by -3 and the top by +2. Okay, why? It's because the top becomes 8 equals 36a minus 18b. The bottom becomes 27 equals -21a plus 18b. All right, why is this important? Because we got a negative and a positive. These are going to cancel out, okay? So those, boom, when we have to add these equations. That's what elimination's all about. We add them together, boom, that goes away. 36 plus 21 is 15a equals 8 plus 27 is 35. Ooh, so not great. I was hoping for nice whole numbers here, but I mean, for the solutions for A and B. Looks like we won't, but that's okay. And then we divide both sides by 15. And they both are divisible by 5. So I get 7/3 equals A. And now let's solve for B. So I'll take either of these equations. Let's go with the top one. 4 equals 18A minus 9B. Plug in 7/3 for A. And I get 4 equals, these cancel out to 1 and 6, right? 6 divisible by 3. 42 minus 9B. Minus 42 minus 42. Negative 38 equals negative 9. Oh my God, these numbers are not very good. So then we divide by negative 9. Negative 9. We get B equals 38 over 9. So that always throws me for a loop when I see numbers like this, because the first thing I'm thinking is, did I do something wrong? And maybe I did. I'll have to go back and recanvas, and I'll plug these in and make sure that they look okay. But they want A times B, which is going to be a really messy number. 7/3 times 38 over 9. And there's nothing we can even cross cancel. 210 plus 56, 266 over 27. That is insane. So now it's multiple choice is actually there. I guess that's it. See, that makes me feel a little bit more comfortable. But really what I should do is I should plug these into both of those equations and make sure it makes sense. It's just not going to be pretty. So when A equals 7/3, so that's 6, is 42. Minus, what do we get for B? 38 over 9, right? Minus 38. We do get 4, and then let's plug it in here. I'm just going to do it mentally. 49/3 minus 3. 49 minus, hold on, 3 times, no, 2, 30, 76. 49 minus 76 is 7, negative 27 over 3, which is negative 9. Okay, I just did a quick mental check. What I did was I plugged in my values for A and B into these two equations just because it's easier than plugging it into all this. And it seems to work, so I believe this is the right answer. Let's see. All right, sweet. Hard systems of linear equations. Just let you know that on the last SAT, I saw nothing this complicated, at least for the last couple. Just a heads up. And I believe that people said that the SAT in November was also on the easier side. So let me see if I got any questions here. Hey, what's up, Charles and Austin? Did I have an error dividing by 2.1 in which question? Which one was the? Can you let me know which question, Ahmed? And I'll go ahead and take a look. Dividing 2.1. All right. Well, I'm not sure which one you're referring to, so I'm going to leave it at that. We are done with the problems for today. Hope you guys found that useful. And once again, we're going to be doing live streams for SAT problems from Khan Academy every week. But I have an announcement if you're watching. We are going to be starting a brand new schedule next week. Not next week, after Thanksgiving break. And I'd love your feedback to hear your thoughts on what should be included, though I think I have an idea. It's going to be a combination of SAT problems, of course, straight from the source. A combination of SAT, ACT problems, IC problems, and then one day of supercharged study tips and different protocols, routines, etc. to maximize your output as a student. So that's it. Thank you guys so much for joining, and I'll see you all next time. Take it easy.